Hey, oh, hey! Guess who's back with another fun chapter? Me, of course. We are at the onset of a chapter that will actually help you to better understand the physical world around you. Yes, we are going to learn how to calculate the surface area and volume of various solid shapes. But before we do that, we must recapitulate what these terms really mean. So, where to build a strong foundation? Let's cement. Now, we have studied in our previous classes that every 2D figure has a quantity called area and a quantity called perimeter, right? Like for this rectangle. This 2D space or region covered by the rectangle is its area, and this 1D outer boundary is its perimeter. In the very same way, every 3D figure has a quantity called volume and a quantity called surface area. Like for this cuboid, this entire 3D space covered by the cuboid is its volume, and this 2D outer boundary or a shell, so to say, is its surface area. So, loosely speaking, area and volume are related in that they are spaces or regions covered by 2D figures and 3D figures respectively. And perimeter and surface area are related in that they are outer boundaries of 2D figures and 3D figures respectively. Perimeter is the 1D outer boundary of a 2D figure and surface area is the 2D outer boundary of a 3D figure. So, got a clear idea about surface area and volume? The surface area of a 3D figure is just the area of the complete surface, right? So, just like we calculate the area of 2D figures in square units, surface area is also calculated in square units, like square millimeters, square centimeters, square meters, square kilometers, and so on. But why do we use square units? Maybe because we are multiplying the length and the breadth. 4 meters into 2 meters is equal to 8 square meters. While some may argue that this really is the reason, the actual reason why we use square units is fair and square. Actually, it is just squares. Confused? Allow me to show you. We know that a line has just one dimension, its length, which is why it is a 1D figure. And the length is measured in millimeters, centimeters, meters, and so on. Now, if we take a line of say 1 meter and extend it perpendicularly by a distance of 1 meter, we get a common shape called a square. Since the line was 1 meter long and it got extended by a distance of 1 meter, the area covered by the square is said to be 1 square meter. Similarly, if a line of length 1 centimeter is extended perpendicularly by 1 centimeter, the area of the square so formed will be 1 square centimeter. So, now that we know the area of this square, we can actually use a group of such squares to approximate the area of any figure. Interestingly, the smaller the squares we use, the closer their combined area will be to the area of the figure in question. Isn't the logic pretty amazing? Even I was amazed when I learnt it the first time. Now, let's move on to understand the units of the next quantity, the volume. To measure the volume of a 3D figure, we use cubic units like cubic millimeters, cubic centimeters, cubic meters, and cubic kilometers. But why do we use cubic units? Does it have anything to do with cubes? Bingo! Just like we use squares to approximate area, we use cubes to approximate volume. So, very much like the previous example, we take a line of length 1 centimeter and extend it perpendicularly by a distance of 1 centimeter to get a square of area 1 square centimeter. Now, this time we take this square and extend it perpendicular to its surface by 1 centimeter. We get a cube, the volume of which is 1 cubic centimeter. And now that we know the volume of this cube, we can easily use a bunch of such cubes to approximate the volume of any 3D figure. Here again, the smaller the cubes we use, the closer their combined volume will be to the volume of the 3D figure in question. So remember, surface area. The 2D outer area of a 3D figure is measured in square units. And volume. The 3D space occupied by the 3D figure is measured in cubic units. So now that your basics are clear, let's move on to understand how to find the surface area of some common 3D figures. Let's begin with a cuboid. As we already know, a cuboid is just a solid which has 6 rectangular faces at right angles with each other, like the ice cream block we were discussing a while earlier. Clearly, it is a cuboid. So the dimensions here are the length, the breadth and the height, which are abbreviated as L, B and H respectively. So now, finding the area of this box is easy peasy. All we need to do is find the area of each of the rectangular pieces and then add them all up. And if you notice, you will be able to see that pieces 1 and 2 are identical. Pieces 3 and 4 are also identical, and so are pieces 5 and 6. Then, the area of each of these two identical faces is L into B, right? Similarly, the area of each of these two faces is B into H, and the area of each of these two faces is H into L. So, on adding all of them up, we get L into B plus L into B plus B into H plus B into H plus H into L plus H into L. Now, on adding the like terms and then taking 2 common, we finally arrive at 2 into LB plus BH plus HL. This is the formula for finding the total surface area of any cuboid. Here, L, B and H are just the lengths of the 3 different edges, and the rectangular pieces which form the edges of this cuboid are called its faces. So, now that we have learned how to calculate the total surface area of a cuboid, finding the total surface area of a cube is a cakewalk. What's the difference between a cuboid and a cube? A cube is also a cuboid, but here the length, breadth and height are all equal. So instead of using L, B and H, we can simply use S here. Then the area of each of the identical faces will just be S squared, and the total surface area of this cube will be 6 into S squared, which is simply 6S squared. Here, S is just the length of each edge. That was so simple, wasn't it? We learned how to find the total surface area of cuboids and cubes. Now, total surface area actually reminds me of another quantity called the lateral surface area. Lateral as a word has something to do with sides, and lateral surface area just means the area of the 4 side faces excluding the top and the bottom. So, the lateral surface area of a cuboid will be H into L plus H into L plus B into H plus B into H. So, on simplifying, we just get 2 into L plus B into H. Similarly, the lateral surface area of a cube will just be 4 into S squared, or simply 4S squared. Well. This was a pretty long video, but you learned so much. The cement of the foundation has been laid. It's time we let it settle. But how do we ensure that the foundation remains strong? By practicing questions. Why wait then? Let's quickly summarize and off you go to practice. So in this video, we learned how to find the total surface area and lateral surface area of cuboids and cubes. We saw that the total surface area is simply the area of the complete surface of a 3D figure. It is measured in square units. The volume is simply the 3D space occupied by a 3D figure. It is measured in cubic units. The total surface area of a cuboid is calculated using 2 into LB plus BH plus HL. Here, L, B and H are the lengths of the 3 different edges. The total surface area of a cube is calculated using 6S squared, where S is the length of each edge. The lateral surface area is just the area of the 4 side faces excluding the top and the bottom. The lateral surface area of a cuboid is calculated using 2 into L plus B into H, and the lateral surface area of a cube is calculated using 4S squared.